is the challenge, connecting two distant shores with one of the longest sea bridges ever built. Before construction could begin, engineers needed to understand every kilometer of this massive crossing.
Experts first studied whether such an ambitious project was economically and technically possible.
With approval secured, the massive survey operation began.
Survey vessels started mapping the underwater landscape with incredible precision.
Thousands of sonar pulses revealed the hidden shape of the seabed below.
Every underwater feature had to be carefully documented.
Drones and aircraft captured precise elevation information across the region. The coastline was mapped in extraordinary detail. Satellite imagery helped create a complete picture of the future bridge route. Scientists began studying the behavior of the water itself. Special instruments measured currents, tides, and wave activity. Understanding underwater currents was critical for future foundation design. Engineers collected data for months to understand seasonal changes. Weather stations tracked the forces that would challenge the bridge. Wind data would help engineers design for extreme conditions. Past storms revealed the worst conditions the bridge might face. The next task was exploring what lay beneath the seabed. Seismic surveys uncovered hidden rock formations and sediment layers. Every geological detail was carefully studied. Now it was time to drill deep into the seabed. Core samples would reveal the true strength of the ground below. These samples showed exactly what future foundations would stand on. Every sample was tested for strength, stability, and durability. Protecting marine life became a major priority. Water quality monitoring continued throughout the project. With the data complete, route planning could begin.
Thousands of possible routes were carefully evaluated.
Final path balanced safety, cost, and environmental protection.
Attention now turned to designing the structure itself.
Every component had to survive decades of harsh marine conditions.
Engineers also prepared for seismic events.
Different bridge types would be used across the route. Construction logistics became the next challenge. Bridge components were produced on an enormous scale. Thousands of concrete sections would form the bridge deck.
Specialized equipment began gathering at the site.
One of the largest marine construction fleets ever assembled moved into position. Seabed preparation marked the beginning of physical construction. Weak materials had to be cleared away. Every foundation location required pinpoint accuracy. The bridge would stand on thousands of deep foundations. Each pile was driven deep beneath the ocean floor. Construction advanced from many locations at once. Every foundation was thoroughly checked. The future bridge was beginning to take shape. Steel reinforcement strengthened every critical element. Huge volumes of concrete created permanent support structures. Precision remained essential at every stage. The project advanced kilometer by kilometer. Production continued day and night. Every component underwent rigorous testing. Powerful steel tendons locked the structure together. Now came one of the greatest engineering challenges. Special navigation spans would allow ships to pass beneath. Bridge towers began reaching into the sky. The towers grew taller with every passing week. These structures would support some of the longest spans. Next came the bridge's defining feature. Each cable carried enormous loads. Progress continued despite setbacks. Long-term durability required advanced protection.